After you've learned about binary numbers, let's talk about how to add and subtract binary numbers. Welcome! I'm Cons. I got a master's degree in computer science and currently work as a graduate research assistant in computer science, and I'm here to help you to learn computer science with Python. Before adding two binary numbers together, first revisit how you would add two decimal numbers on a piece of paper. So for this example, we have the number 2345 plus 189. And to add them by hand on a piece of paper without the help of a calculator, we first write 2345, and under it we're going to write 189, and we make sure that the last digits align. Then we draw a line under them and we leave some space after the second number and add a plus over here. Now we add digit by digit, and when we add 9 plus 5, we get 14, and we write down the 4. The 1 is carried over to the next row of digits. Here we are going to add 4 plus 8 plus 1, which is 13, and we're going to get the 3 and carry over the 1 to the next column of digits. In this column, we add 3 with 1 and 1, which is 5. We don't have to carry anything over. And the last digit, we are adding 2 and an invisible 0, which results in 2. Adding two binary numbers together works in the same way as you would add two decimal numbers on a piece of paper. But instead of plus, we're going to use XOR. And as you remember from the video about Boolean algebra, which you can find up here, the XOR is only true when both values are different. So when we have 0 XOR 0, we get 0. When you got 0 XOR 1, we get 1. When we got 1 XOR 0, we get 1. And when we got 1 XOR 1, we get 0. Now we would like to add the numbers 10 in decimal and 12 in decimal in binary. So first we have to convert 10 to a binary number, and the binary representation of 10 is 0101, and the binary representation of 12 is 1100. Now we're going to write the 10, 1010, and under it the 12, 1100. We draw a line, we leave some space, and add the XOR sign here. Now we add each digit with an XOR. 0 and 0 is 0, 1 and 0 is 1, 0 and 1 is 1, and 1 and 1 is 0. However, when we add two ones together, 1 plus 1, we get 2. And when we add those two in binary, 1 plus 1, we get 1, 0. And when we add two ones together, we actually get a 2. And this generates this carry bit, which we are going to carry over to the next column of digits, and then we add this invisible 0 up here with this 1, and that results in 1. And this is the result when we add 10 in binary and 12 in binary together. And we can check that our result is actually correct by adding all the bits together. So we have 16 plus 4 plus 2, which results in 22 in decimal, and when we add 10 to 12, we get 22. We can also check this calculation in Python. We enter x0b and then our 10, which is 1010. Then we enter y with 0b as 1100, and we can check x is 10 and y is 12. And then we store the result of x and y in z, x plus y, and print it with a formatted string that will print out our result as a binary. We have the formatted string f, then we have braces z with the modifier b, which will print out z as a binary number, and we can see that results in 10110. And if we enter Z here, we can see it is actually 22. And if you enjoyed this video so far, make sure to give it a like so it can spread to more people and more people can learn about adding and subtracting binary numbers. Before we talk about how to subtract binary numbers from each other, let's have a look on how to represent negative numbers in the binary system. If we got a fixed amount of bits to represent our number, like here we have 4 bits, we can only represent a certain amount of numbers. And for 4 bits, we can represent the numbers from 0, starting from 0, to 15, which represents the number 1, 1, 1, and 1. If we now want to represent negative numbers, we have to make some space to store those negative numbers. And usually we allocate half of our bit space to the negative numbers. That results in a number representation going from -0 over 0 to 7. So if we now want to represent our 10, we need an extra bit. And for that, we're going to turn our 10 from decimal into a 5-bit binary number, which is just done by adding an additional 0 in the front. And the first way to represent 10 as -10 is using the ones complement. The ones complement uses the negation to flip every bit of a number. So to represent -10 in the ones complement, we're going to flip every bit to 1, 0, 1, 0, 1. And this is the negative representation of 10 in the ones complement. However, the ones complement has one big issue. When we have a look at the 8-bit representation in the ones complement, we can see that the number that is only composed out of 0 bits is 0. And when we negate every one of those bits, we get -0. Having a number system that represents one and the same value in 2 different ways makes it extremely difficult to do operations on. Because for every operation that involves the number that is represented in 2 different ways, special cases have to be respected. And to get rid of the ones complement, the twos complement exists. The twos complement uses the ones complement and adds a 1 to that number to represent its negative form. So let's look back at our 10 in decimal, which is written down here in binary. If we want to build the twos complement of it, we first negate every bit, which will result in 1, 0, 1, 0, 1. And then we add a binary 1 to it. And first we add 2 ones, and when we remember that is 0, and we carry over 1 bit, we get another 1 here, because we have 0 and 1, which is 1. Then we have 0 and 1, which is again 1. Then we have 0 and 0, which is 0. And then we have 1 and 0, which is 1. And 1, 0, 1, 1, 0 is the representation of -10 in the twos complement. And to check that the definition of the twos complement is actually sound, we're going to try to get the -0 in the twos complement. So first we define that we have a 0, and that is represented with 5 bits in binary. Then we first do the negation of every bit of the 0, which gives us 1, 1, 1, 1, and 1. And then we add a 1, a single 1, to this value. And when we do that, we add 1 and 1 is 0. We carry over a 1, and we have 1 and 1 again, which is 0. We carry over another 1, and so on. 1 and 1 is 1, carry over a 0, a 1, 1 and 1 and 1, carry over a 1. Until we get to the last one, where we have 1 and 0, which is a 1. However, we decided that we only represent 5 bits, so this 1 is disregarded. And with that, we can see that we want to get the twos complement of 0, we get the exact same number as we had before in the binary representation, and therefore don't have to deal with different representations of the 0. Now that you have seen how to represent negative numbers with the twos complement in binary, it is time to talk about the subtraction. When we want to subtract 2 numbers, a minus b, we can also formulate that as a plus minus b. And we will do the exact same thing when we subtract one number in binary from another one. For example, we want to do the subtraction 10 minus 12. For that, we have 10 minus 12 and reformulate that as 10 plus minus 12. Now we need the binary representation of both of those. The binary representation, if we remember, of 10 is 0, 1, 0, 1. And the binary representation of 12 is 01100. And now we have to turn this 12 into a negative 12. For that we're going to use the 2's complement, so we flip every bit of our 12, which results in 11001, and then we add a 1, which will then result in 00101, and this represents minus 12 in the 2's complement in binary. Now that we have the binary representation of 10 and minus 12, we can do the binary addition as we have seen earlier in this video. So we write down both of those numbers so that the digits align, and then we're just adding them together. 0 and 0 is 0, 1 and 0 is 1, 0 and 1 is 1, 1 and 0 is 1, and 1 and 0 is 1. But now we would like to know what is the result of our calculation. We can see that this is a negative number because all negative numbers in the 2's complement have the bit on the far left side set to 1. This bit is also called the most significant bit because it represents the highest power of 2. And to figure out what value this is, we're going to use another trick of mathematics, which is that a is the same as minus a. So what we're going to do, we're going to apply the 2's complement to this number to figure out what it is. The 2's complement of this number is of course the flipping of every bit, which is 1, 0, 0, 0, 0, and then we're going to add a 1 to it, which will result in 0, carry 1, 1, and then 0, 0, 0. And now we can see this actually represents the number 2. And we remember that it is a negative number, so we can write down that 1, 1, 1, and 0 is actually minus 2 in decimal. Subtracting binary numbers from each other concludes this video. And I encourage you to try out all the things you have learned in this video yourself, and for that I prepared a little assignment. Try to add those two numbers that are represented in decimal in binary, and do the same with the subtraction by subtracting this number and this number, which are also represented in decimal in binary. And when you have done the calculations, convert the binary numbers back to decimal and check the results. I hope you enjoyed this video. If you got any questions on this video, make sure to let me know down below in the comments. And if you want to catch up with me, join our lovely Discord community. Don't forget to subscribe and hit the bell icon so you get notified when I release a new video on computer science and programming. Big shout out to my Patreon subscribers for their support, and if you want to learn how to multiply two binary numbers together, check out this video over here. I wish you a fantastic day and hope to see you in my next video. Bye bye!